Okay, last one on the review. So I would probably want to graph this first. So negative 3, 0, 3, 2. That's x. Y is 6, negative 7, and z is, oh, okay, find the missing point. All right, and we got to make it a rectangle. So here we go. Negative 3, 0, 3, 2, 6, and it looks like that's y, w, x. Okay, a couple things we got to be careful of. We've got to make sure when they give us w, x, y, z, what we have to do is, once we get a pattern started, say we call that w and x, that has to be y. Z has to be somewhere over here because it's got to go kind of in order like that. You know, it has to flow. You can't go, this would be a mistake. We can't do something like this where it's W, X, Y, Z. Can't bounce back and forth like that. It's got to have a flow to it. It's either got to go clockwise or counterclockwise, but it's got to flow. So that's something that's important when you get the next problem, if this comes up. So we're looking for Z, so that we make this a rectangle. Well, let's first, what I would probably want to establish is that really a right angle? If it's a rectangle, it's going to need 4 right angles. Okay? And we can guarantee that on a graph. Slopes have to be negative reciprocals, right? So one of the things I'll do is I'll take a look at this. The rise is 2. 1, 2, 3, 4, 5, 6. Looks like the run is 6 on WX. So let's just take a look at the slopes here. WX, it has a slope of, rise is 2, run is 6, and it's positive. Okay, that's equivalent to 1/3, right? And 3 times 2, so we can reduce it to 1/3 if we want. All right. And for xy, we needed, let's see, yeah, 3 across, 9 up and down. So the rise is 9, the run is 3, but it's negative because when we travel left to right, it's heading down. All right, so let's see. We can take out a 3 in both and knock out the 3's, and it's negative 3 over 1. All right, that's great. If we can keep that going, it's going to be a rectangle. Now, what I would do if it's a rectangle is WX would have to have the same rise and run as YZ. So I'm going to come back 6 and come down 2, and then I've repeated that, right? So we've got the 6 and 2. All right, same thing. So that's going to be perfect right there. And then we just got to make sure that this one works. Let's see. Hopefully it does. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Okay, so we've got everything we need here. It's perfect. Looks like all the dimensions are right on for us. So let's go through and see what happens. All right. How do you know that WXYZ is a rectangle? So we got to find Y. And then how do we know it's a rectangle? So Y, 1, 2, 3, 4, 5, 6, 7, 8. Looks like negative 9. We think Y is negative 9. So let's finish it off. YZ. Slope is again 2/6. And WZ. We have the same numbers again. You don't have to redo all the work. Just show it. It's a rectangle because, let's see, WX is perpendicular to XY. all the way around. XY is perpendicular to YZ, and so on, because their slopes are negative reciprocals. Okay, they're perpendicular because their slopes are negative reciprocals. And perpendicular segments form right angles. Okay, so WXYZ has 4 right angles. That makes it a rectangle. Okay. So we're trying to make sure we explain it fully, take care of that. So did we... Okay, so check, we did that. Find the length of each side of the rectangle, so now we got to go length, but good news is we can use the same exact numbers. Okay, so the length of every side, I'm going to go with lengths of every side. Okay, so WX, we had a 2 squared plus 6 squared equals, just call it D squared, it's fine. I call it D for distance, right? So that's WX, it's going to have those numbers, okay? That's going to be 40, and we square root both sides. So WX equals, its length is the square root of 40. All right. Now we kind of have to do this for all of them. Okay, next is XY. That one had 3 squared plus 9 squared. No, wait a minute. That's 90. 81 plus 9, 90. Okay. So square root both sides, and it doesn't work out nice, but we do know it's the segment symbol square root of 90. Okay. Keep going. YZ. All right, that's back to this. And likewise for ZW. You can do this a little bit. So ZW equals square root of 90. Okay, so that's the length of every side. All right. What's the next question? If one unit on the graph represents 3 meters, determine the area of the rectangle. It is a rectangle, so we don't have to box it in and add up all the triangles or anything like that. What we really do have is area of a rectangle's length times width. Okay. Now on the grid, what we have is, it doesn't matter which one uses length or width, right? Let's say the square root of 90 is our length. Now be careful. On these new calculators, you have to tab out or right arrow out of the square root symbol. Okay. That way it separates it and lets you get out and, finish off the square root. So make sure when you do that, that happens. Okay, times the square root of 40. That's square root of 3600. That must be 60. I'm just thinking here for a second, make sure that's right. Something doesn't seem right there. Okay, it's good, but that's on the grid. Okay, that's the graph length. But what they're saying is if every single unit of measure on the graph represents 3 meters, so the area in meters is 60 times 3. So the area of that is 180 meters. Now let's see if there's anything else that we're supposed to calculate here. Nope, that's it. All right, so that's the end of that problem, and that's it for the videos. Thanks for tuning in, and hopefully this is helpful to your preparation.